morning, algebra students. How's it going? Today I want to talk about why we've been factoring. So we've been talking a whole lot about, was it factoring quadratics, also being trinomials. Okay, and we've just been working with expressions. Okay, and it's important. We're going to talk about right now what an expression is versus an equation, and then eventually we'll talk about how we're going to apply this stuff to functions. So expressions, I always tell people, is like practice. Okay, and equations are more like applications. Okay, so the game itself. Okay, so what we've been saying is things like this. We said, well, x squared plus, I don't know, 5x plus 4, right? And we're saying, hey, a is equal to 1, right? A is equal to 1, b is equal to 5, and c is equal to 4. A is equal to 1, so we can continue. And what we're looking for the factors of 4 that add up to 5. In other words, give me two numbers that multiply to make 4, but add up to make 5. So those are 4 and 1, right? 4 times 1 makes 4. 4 plus 1 makes 5. So we're saying x plus 4 and x plus 1, right? And we said that this was standard form and this was factored form. And nobody asked why. Nobody asked why we're doing this, guys. You should be a little more cynical and ask a few more questions. Why are we doing this? Well, I'm going to tell you why we're doing this, because this form is going to tell us something about graphs when we get to functions, which will be expressions. Equation functions will be the next thing. But it's going to allow us to solve equations. So if I give you this x squared plus 5x plus 4. So say I give you this. I said x squared plus 5x plus 4 equals 0. I said, hey, solve this. Well, a lot of you guys are like, all right, I'm going to subtract 4 from both sides, right? And I'm going to say x squared plus 5x equals negative 4, and then I'm going to subtract 5x maybe. Maybe if you're really savvy, you can factor out an x, and you say x squared is equal to negative 5x minus 4, and a lot of you guys say, oh, the opposite of the square root. Square is the square root, and you're going to get this. X is equal to the square root of negative 5x minus 4. It doesn't work. It doesn't work because there's no way, there's no operation that can separate these. Yes, this is what x is, but I also have x in my definition. It's like defining a word with the same word. I don't know about you guys, but when I was in grade school, you weren't allowed to do that, right? So this doesn't work. Does not work. Okay. So to solve quadratic equations, we need a new method. Okay, your linear stuff, right? The inverse operations, it does not work. So linear rules don't necessarily apply. We'll talk about sometimes when they do. There will be some times where you are able to use some of those linear rules, and this is also true. When we get our final answer, like this will be true. This statement is true. So the problem is that it doesn't help us. Okay, that it doesn't help us to solve the equation. So today we're going to talk about, hey, how am I going to use this to solve some equations? Now, the first thing we got to understand, okay, is we're factoring. So say I said I had two numbers. Let's call them x and y. And I'm multiplying these two numbers, x times y, and I'm saying that their product is 0. So x times y is equal to 0. Now think about that for a second. Think of two numbers that you can multiply together and their product is 0. Well, there's 1 times 0, and 2 times 0, and 0 times 0, and 10 times 0. And what you really should come to the conclusion is if I'm factoring and the product is 0, either x equals 0 or y equals 0 or x and y equals 0. So in other words, if I'm multiplying two numbers and my answer is 0, one of them has to be 0 or both of them have to be 0. Okay? So this is an important fact to keep in mind, and it's something that we can use as a tool to our advantage. Okay? So we're saying the product of two numbers is 0, one of them has to be 0. So let's say we're given this. Okay, this is what we were doing. We were factoring and we were getting into this form. Well, I've got two numbers and they're multiplied by each other and their product is 0. Okay, so if their product is 0, then, and this is multiplication, right? There's no symbol in there, so this is multiplication. One of these or both of them have to be 0. Okay, so here's what we're going to do. We're going to split this into two different equations. We're going to say x minus 7 is equal to 0. We say x plus 2 is equal to 0. And now we have a linear equation. X plus 7, well, then x is equal to 7, right? 7 minus 7 is what equals 0. And over here, I'll subtract 2, right? Negative 2 plus 2 is equal to 0. So the solutions, and I'll say solutions, to this problem are 7 and negative 2. This is why this didn't work, because your linear rules, if you guys remember, linear equations, either they have an answer or they don't. It's a one answer or no answer situation. Here, there are two. And we'll talk about why that happens. If we had gone ahead, oh boy, let's do it this way. Okay. Now, if you remember from about a week ago, if we wanted to multiply these two things, it was first, outer, inner, last, right? So, and 2x minus 7, that's going to be negative 5x. Okay. This was the original problem. This is in factored form, and then we had to split that into two things. Okay. Just to show you that it works, if I plug in 7 squared minus 5 times 7 minus 14, does that equal 0? Well, 7 squared is 49 minus 35 minus 14, and that is true. Okay. And if I plug in negative 2, I want to stop writing. 4 plus 10 minus 14. 4 plus 10 is 14, and 14 minus 14 is 0. So for sure it's true. Okay. So kind of our MO is to get to factored form equal to 0, so we are allowed to split this into two different equations. Okay, so I'm going to go over a few of these, and then I'm going to set you guys those to try some yourself. Please watch the examples and listen. I'll try and go slowly. How much time are we working with? We are at the 8-minute mark. We're very good. Okay, so this one, again, x minus 1 times x plus 4. So this is already in factored form. We don't have to factor it. So what are we going to say? Let's split this into two different equations. Since I'm multiplying two things and their product is 0, let's go ahead and let's say x minus 1 is equal to 0 and x plus 4 is equal to 0. Okay? So what number minus 1 is equal to 0? 1, right? 1 minus 1 is equal to 0. And what over here, what number plus 4 is equal to 0? Well, negative 4. Okay. A couple things. You can leave it just like this. X equals this. If you want to put them together, do not do this. No. That's an XY coordinate. No. These are both X's. So no. Do not do that. Okay. If you really want to, you can write them in step builder notation. So you got to draw a little funny curly Q thing, and then you can say 1, negative 4. So if you really are so inclined, you can write it like that. If you want to get really fancy, it's the set of x such that x equals 1, negative 4, and 1. you really want to get fancy, okay? But let's stick to either this or just leave it like this, x equals 1 and x equals -4. That's totally fine, okay? Good? All right, so next one. Now, this one's not factored, so we're going to have to apply what we've been doing the last couple of days. So what do we got? A is 1, B is -4, C is 32. So what are my factors of 32 that add up to -4? Did I do this one right? I don't think I did. Did I write this one down there? -4 plus 4 minus 32. Sorry. So it should be my mistake. Otherwise, it won't be factorable. And we're plus 4 minus 32. Okay. So this should be -32. My mistake. When you've done enough of these, you can kind of spot things that are a little bit awry. So my fault for writing this down wrong. Okay. So what are my factors of -32 that add up to 4? So again, factors of -32, one has to be positive, one has to be negative. Since they have to add up to a positive number, the positive number has to be bigger. Okay, so let's start again. If you don't need to list them all, you don't need to write all of them down. So let's go with -1 and 32. No. -2 and 16. No. -4 and +8, and you can stop right there. Okay, so -4 times -8 makes -32. And -4 plus 8 makes 4. So 8 minus 4 is 2. Okay. So let's rewrite this now in factored form. Okay. So we said, what do? We're going to get our parentheses out. And what are we going to say? I'm given x minus 4 because it was negative, and x plus 8 because it was positive. And now we're back to those other problems. Okay. I know some of you guys are going to get to the point where your gut instinct's going to tell you, oh, just switch the numbers. It's 4. It's 4 and -8. That's okay for now, but these problems, as you guys go through a little bit more, I told you we had to switch this problem because it wasn't factorable. As they get a little more complicated, that's not necessarily going to be true. Okay, so what are we going to do? We're going to split this into 2 equations. So what do we got? I'm adding 4, so again, 4 and -8. Good? So again, I know your gut instincts to say, hey, just switch the sign of these numbers. That's not always going to be true. So if you see that for now and you're okay with that for now, that's fine, but just be aware that that's going to change in the future. You're not always going to be able to do that. Okay? So again, our process, factor it like we've been doing. Okay? Set 2 equations equal to 0, solve them. Okay? So we have 2 answers, 4 and -8. All right? Here, again, let's do the same thing. Let's factor. A is equal to 1, B is equal to -1, C is equal to -30. What are my factors in -30 that add up to -1? So again, one's got to be positive, one's got to be negative, and again, the negative has to be bigger. So again, what do I got? I've got 1 and -30, no. 2 and -15, no. 3 and -10, no. 4 doesn't go in. 5 and -6, right? So again, 5 times -6 makes 30. 5 plus -6 makes -1. So let's rewrite this in factored form. X, 5 was positive, 6 was negative. All right, and let's go ahead. What's now? We're going to split this into 2. X plus 5 is equal to 0. So I can get rid of the parentheses. And what do we got? X minus 6 is equal to 0. So what do we got? X is equal to -5. And X is equal to 6. Okay, so those are your 2 answers. Again, if you want to get real fancy, -5, 6. Okay. All right, so this one, A does not equal 1. A does not equal 1. But some things we should know, this is a perfect square trinomial. Now, This is one of the ones you actually could solve using your linear stuff, but let's kind of stay with what we know. Well, we do know that that's a perfect square, right, from yesterday, and that's a perfect square, and they're separated by a minus sign. So this would be 3x and 3x, correct? And what do we get? We get a positive 6 and a negative 6. So again, those things we were talking about yesterday, they still apply here, right? So we were talking about those special cases. Again, what's going to happen here, and again, this is what I was telling you guys, you can't always just reverse that number, is that we're going to get two different answers, but they're going to look very familiar, right? One's going to be -2, and again, one's going to be +2, and we'll see why that's important for us later. It's going to tell us something about this when we graph it, but again, when we have a perfect square trinomial like we were talking about yesterday, you're going to get a positive and negative answer. Okay, good. All right, and this last one, I think this might be the last one. Okay, yeah, maybe one or two more. Big thing, people forget it's got to equal 0 in order for this to work, right? So the whole point that we said from the beginning was that we need two factors that have a product of 0. So the first thing you need to do is probably contrary to everything you remember from doing linear equations, which is not move all the x's on one side and on the other. You're actually going to move everything on one side and leave nothing on the other. So this is like, I don't know what you want to call it in sports terms, like an isolation or an overload or something like that, where everything is now on this side and it's equal to 0. Okay? So again, A is equal to 1, B is equal to -16, and C is equal to 64. So what are my factors of 64 that add up to -16? Well, they both got to be negative, so no, no, no. 5 doesn't go, 6 doesn't go, 7 doesn't go, does 8 go? Yeah, it does. -8 and -8. And that's going to be us right there. And this should tell us something. This was actually, when we factored this would be x minus 8. X minus 8 is equal to 0. So believe it or not, for this one, there is only one answer. I can split it into 2, but you're just going to get 8 both times, okay? So this is what we call not the difference of two perfect squares. This is a perfect square. There is only one answer, and we'll talk about what that means graphically when we start working on that next week. There is only one solution for this, for now. There's always two solutions, but at your level of math, you can only find this one, okay? The other one, actually, you guys wouldn't even understand. It's not even on the same number line, so don't worry about it for now. As far as you're concerned, there is one answer to this problem, okay? So pretty much we have three options. There could be no answers, there could be one answer, there could be two answers, okay? If you ever, again, a little algebra 2, whatever this exponent is tells you the maximum number of your answers, okay? So I'm going to go over one or two more, and then I'm going to set you guys to do some of these. I got you guys some more multiple choice. It seems to be working better for some of you guys. So yeah, I'm going to pick 2 of these off of this. Again, when I say it's going to get more complicated, I mean it's going to get more complicated, but that's really not for us. That'll be for 11th grade for most of you guys. Okay. So number 15. Number 15 says x squared minus 5x minus 1 is equal to -5. So first thing, we have to set it equal to 0. So let's add 5 to both sides. And again, what do we get? That problem that we had right at the beginning of class today. Okay, so what are my factors of 4 that add up to -5? So A is equal to 1, B is equal to -5, C is equal to 4. What are my factors of 4 that add up to -5? Well, -1 and -4, right? So what do we got? We have x minus 1, x minus 4 is equal to 0. And so what are we going to do? Let's split that thing into 2, because again, their product is equal to 0. X minus 1 is equal to 0. X minus 4 is equal to 0. And again, what are my answers going to be? 4 and 1. Okay? All right, I'm going to do number 16, and then we'll be done. So not to throw you guys off, I'm going to use A this time. Again, it doesn't matter what the variable is. Typically, we use X just because that's the most common one, and that's what we're going to use when we graph them. Okay, so again, first step, it's got to be equal to 0. So what do we got? A squared minus 6A plus 8 is equal to 0. A is equal to 1, B is equal to -6, C is equal to 8. What are my factors of 8? Add up to -6. Those are guys right there, right? So we'll say A minus 2, A minus 4. And again, what are we going to do? Split into 2 equations. A minus 2 is equal to 0. A minus 4 is equal to 0. So let's add 2. A is equal to 2. A is equal to 4. Okay? So again, we're going to get real fancy. Something like that. Okay? But again, this is pretty foundational stuff. Something you guys got to know. We will probably spend today and tomorrow going over these just in case. But if you have questions, please send them. And thanks for watching.